Good morning, attendees. My name is Miles Free. I'm Director of Industry Research and Technology for the Precision Machine Products Association. On behalf of PMPA, our partners at Gardner, and the Davenport company, I'd like to welcome you to today's demonstration. Sandro Belpano, the Senior Design Engineer, is going to review with you some of the features of this new hybrid concept machine. So this is a concept car. You're looking at a concept car just like you were at a Detroit Auto Show or something. And the concept on this is the combination of the CAM technology with the CNC technology to help you be more productive, more uptime, and more accuracy for your parts. So I'm going to give the mic to Sandro to explain to you all the advantages of this new concept in machining, the future of your shop for multi-volume parts.
On behalf of the Davenport team, I'd like to thank you all for attending today. As Miles said, this is a concept machine, a pre-production prototype of the future of Davenport machine technology. It incorporates the best of the mechanical versatility that you've come to expect from Davenport, along with the CNC technology that we've developed over the last few years for various customers to solve their application-specific problems. This machine we consider to be our super precision machine. It's capable of holding tolerances that you wouldn't expect off of a typical Davenport. It does so with increased productivity and shorter setups, shorter cycle times, and we think returns a superior return on investment for your capital equipment dollars. A couple of the major changes that have happened to the machine here, and I'll step through them as I'm going along here. One of the major changes to this machine is in the revolving head and how we hold the spindle carrier in the bed of the machine. As opposed to older versions of the machine where that revolving head was scraped in with a couple thousandths clearance into the bed of the machine, this version of the machine uses HP technology, which we've had for 10 years, where the bearings on the spindles rigidly hold the part, and we've taken that concept and used those bearings, now 9-inch diameter bearings that hold the entire spindle carrier in the bed of the machine. What this allows us to do is give you rigid, accurate, precise, and repeatable work holding so that your bars are introduced to the same place every time the machine indexes. In addition to rigid work holding of the part, we took a look at how we deliver the tools to the component. And on this machine, you'll notice that the slides are very different looking than it would be on a standard Davenport machine. You know, gone are the days of dovetail slides and tapered gibs and having to adjust them and the issues that go along with them. These slides are modular in nature. They're built on linear rail technology, so the same type of technology that you would have controlling the motion in a high-end CNC lathe or mill is incorporated in this design. Precision, zero clearance, preloaded, very rigid, very accurate, long-running technology. The modular concept comes from the fact that we're not limiting you to using Davenport tooling. If you have, Acme's New Britain's other multi-spindle machine platforms that you're considering rebuilding, for that same investment dollar, you can get one of these machines brand new from Davenport Machine, and you can move those setups from those older, slower, and less accurate platforms onto a Davenport machine and take advantage of all the CNC technology that's available on this platform. So we've taken a look at two of the fundamentals on the machine, being able to put the spindle in the same position all the time, and now being able to take the tool and put it in the same position all the time. Now that those two fundamentals have been solved on the mechanical side, we're able to leverage those advantages with the CNC controls. You now have the ability to offset each one of those spindles independently using the control in 1/10 increments. that's a huge deal for anybody that's run a Davenport. You know, you can't pick a tenth off using mechanical turnbuckles on a machine. But now you have the ability to run your first 5 parts, measure 5 parts off those 5 spindles, and if one of your spindles is running a couple tenths big or a couple tenths small, you go over into the control, you tell it, I want spindle number 3 on my form tool to run a few tenths smaller, and all those parts dial themselves right in, so you're holding a very narrow tolerance band across all your spindles on your machine. Every CNC drive and every CNC position on this machine has independent offset control for each one of your spindles, so you can really dial in your part accuracies to something that you've never seen before. In addition to that, as your tools are wearing, you have a one-touch adjustment. So as your form tool wears and your parts get a tenth or two bigger from nominal, you can go in there on the fly, tell it, I want my form tool to run 2 tenths smaller than it is currently, publish that data, and the next time that it runs a part, that slide will advance a couple tenths farther, and your tolerances will be right back to nominal. This chart speaks volumes about what this machine is all about. So we took the exact same tooling and ran it with the exact same speeds and feeds on our 3 basic platforms. The classic Model B, the HP machine equipped with a HP head, and the new hybrid machine. And you'll notice the Model B machine is in the foreground and the hybrid is in the background. Where the model machine, the part size distribution tends to be very broad, so there's a lot of outliers, you know, big and small parts on that curve. As you stepped up to the HP, you tend to get a much tighter distribution. HP is capable of making parts that are roughly 2 to 3 times better than a Model B is, but the really interesting one is the hybrid. So just to give you an idea, each one of those bars only represents 1/10 of 1 inch. So the hybrid was able to put all of its parts within a 4 or 5/10 band. You know, this is a sample size of about 800 out of a longer multi-hour run, and we think those results are just phenomenal. In fact, one of the jokes that we made while we were testing and measuring these things is there's a downside to buying this machine, and that is you're going to need new micrometers because your old ones just aren't going to be good enough anymore. This is the same data presented a little bit differently, so you can see over time exactly what the machine is doing. The grouping at the bottom there is your standard Model B, and you can distinctly see where the 5 different spindles are making 5 different size parts. There's a lot of variation within the spindle itself and a lot of variation within the head. The HP is the grouping above it. Everything seems to overlap a lot better, so they're making similar sized parts, but there's still a lot of variation to an extent within them. That grouping on top, that looks like a straight line probably from where you guys are, that is what the hybrid can do. It'll make 800 parts, and it'll make all of them within 4/10 of an inch. Granted, that is this capability study in this particular material running these speeds and feeds, but you can take that comparative, analysis and, extrapolate it to the kind of parts that you guys are running right now. So, one of the things we looked at when we were designing this machine is, nobody likes shaving. It's one of those things that everybody has to do, but, essentially keeps your wives or your customers happy. But if you can get rid of shaving, there's a lot of benefits to it. In a 5-spindle machine, shaving takes up one of your 5 side working positions. So it limits the amount of complexity that you can have on your part, and it limits the length of part that you can do. So we think you can eliminate shaving on a Davenport. Some of the benefits of that, when you look at setup skills and what's involved in setting up one of these machines, 30% of your setup skills are about the shave tool. Trying to dial out taper, trying to dial size in properly. And by not having the shave tool even in the machine, it just makes your setups easier, makes your setups faster, makes the machine more productive in the long run. We believe that this will allow you to manufacture what have traditionally been considered 6-spindle parts on a 5-spindle machine. One of the nice features that we've added to this machine is the ability to have a 2-axis CNC slide up in the 4th position. That slide will accept Davenport tooling as well as standard lathe stick tooling. So if you want to do profiling, contouring, angular tree pan grooves, single point turning on difficult to thread materials, you now have that ability with this slide. And in addition to doing OD work, that slide is capable of holding bore bars, so you can do internal profiles and tree pan grooves, deburring operations, and things of that nature. You can even gang those tools. So with a single slide and a single setup, you can do OD work and then swing the bore bar into the center of the part and do ID work using the exact same slide. One of the nice advantages of that is you can still have a drill or a reamer in 4th position, let's say, have it come in and do its work, and then after it backs out, the bore bar can swing in and then do additional work to it. So even though you're a 5-spindle machine, you're now able to put up to 7 end working tools into your parts, and that's a big deal as far as part complexity goes. That slide is in the 4th position on this particular machine, but it'll also be available in 3rd, essentially a twin of that slide laid down 72 degrees on its side. So to control all of this new CNC technology that's on the machine, we've put a new state-of-the-art CNC control package on the machine. What you have in front of you is a 15-inch color touchscreen. So when you're going through trying to find the features that you want, there's a lot more real estate. There's not as many pages to flip through. We've changed the entire layout of the machine so that it's easier, quicker for customers to understand. And the touchscreen was a big deal for us because nowadays with your iPhones and your iPads, everything's touchscreen, and that's how people think. They want to be able to reach out and touch a screen. So when you're trying to put in offsets into the machine, go to the offset page. It tells you your 1st position slide. It tells you each of your spindles. You just go up, touch it, type in the button, the offset value that you want, go back in here, propagate it, and it essentially goes in. So it's all state-of-the-art hardware. We think this is going to be a big plus to the industry. A lot of the newer operators coming up, they don't have that mechanical aptitude that you used to see out of operators 20 and 30 years ago. They're used to the controls and they're used to the touch screens, but we're trying to keep in mind both the new operators and the operators that are already in the shop. The interfaces are laid out in ways that make sense to a Davenport operator that's used to running a Davenport machine. If you take a look at the machine, we put a lot of effort into chip evacuation in the machine. A lot of the newer alloys, more difficult to break a chip. They tend to be a lot stringier. So we took a look at all the places where chips tend to build up, got rid of the center drive, got rid of the tool pull stop because you don't need it anymore. You essentially have a digital version of the tool pull stop on the controller. So all the places where chips used to build up around the head, they're all gone. We're trying to allow the chips to fall down through the machine. You'll notice that there is no chip funnel underneath, and the entire chip evacuation system has been completely redesigned for this model. There's a high volume chip conveyor in this machine, so there's no more 4-inch diameter auger. It's designed to be a washdown design. So as the chips are being generated in the machine, everything gets funneled down into that conveyor, and the conveyor will bring those chips back out of the machine. It's designed to get more chips out of your machine without manual intervention, keep more oil in your machine so you don't have to spin all that stuff out and recover it. We've also taken a look at the bed casting. Now, taken a look at strategic areas and reinforced it to allow us to hold those tighter tolerances, particularly around the 8-position slide. Tends to be one of the weaker areas in the machine. It's been significantly reinforced so that we can hold the accuracies that you've seen in the previous slides. Now, one of the nice benefits of having the bearings on the head is that we were able to take a look at our index times, which are already the fastest index time in the multi-screw machine market at 0.4 seconds. And in certain situations, we're able to reduce that index time to 0.25 seconds. So if you take a look at a not atypical Davenport part that's running at 2 seconds right now of total cycle time, if you can take your cycle time from your index time from a 0.4 second to a 0.25 second, you just put 7.5% more parts in the bucket at the end of the shift without changing the speeds and feeds or the way that you're actually running the part. All we've done is reduce the non-cutting time in the machine. Along with the idea of modern parts being made out of more difficult materials to cut, this machine has high pressure coolant capabilities. So on the floor right now is a chip blaster unit. The machine is capable of handling up to 1,500 PSI of coolant, flowing 10.5 gallons per minute. And with the programmable 8-port manifold that's ceiling mounted so that you can keep all the coolant lines up and out of the way, we can provide coolant to up to 8 tools simultaneously in this machine. That means that you can get coolant to all of your end spindles, whether they're revolving or stationary, along with your form tools and cutoffs to make sure that your chips get evacuated properly, and that you get the best tooling life that you can to keep your machine up and running that much longer. So the machine in front of you today is a 7/8 capacity machine, which is traditionally what Davenport considers our oversized model. This year we've added 1-inch capability to the Davenport, and the hybrid will be no different. We'll have the ability to make parts all the way up to 1 inch, along with the ability to pick off those 1-inch parts and pull them through a bench hang tap if you require. We see a lot of need in that niche market between 7/8 and 1 inch, where some of the older multi-spindle screw machines are being decommissioned, and the demand for that particular range of parts seems to be increasing significantly. We also added a 3/8 capacity machine to this line, specifically with high-speed options on it. So spindle speeds of 6,000 RPM and the index speeds that we were talking about earlier at 0.25 seconds. So when you're dealing with small diameter parts that already have short cycle times, now they can be even shorter so that you can be that much more productive. This machine's a lot brighter than a lot of the machines that you guys are going to see in your shop. We've really taken a look at the lighting on this machine and enhanced it significantly. There's 4 banks of very high-powered LED lights in this machine. There are no shadows in the tool zone, so you can see exactly what you're doing when you're changing inserts and things of that nature. The lights themselves are going to last longer, use less energy, and create less heat on the inside of the cabinet. So, what kind of parts are we targeting with this machine? It's basically things that you couldn't do on a Davenport before, but you always wish you could because you need more of them than you're capable of. Angular tree pan grooves that are precision. The ability to take tools and make it do all kinds of weird geometry is something that this machine brings to the table. Tighter length control because there are no more thrust rings in this machine. The head doesn't float around. It's rigidly held in a set of bearings. 10 RMS on seal faces. When you're trying to hold tight finishes, the ability to have everything from the spindle all the way to the tool rigidly held with no preload, with no backlash and high degrees of preload and stiffness is critical. Aerospace alloys, tough materials like A286, no lead brasses, no lead steels, things that cause difficulty in machines that have less rigidity. And 20 thousandths of wall thicknesses. You start getting into really thin materials there, everything needs to be held very tight so you don't start tearing and ripping your parts. That's our general presentation for today on the Davenport hybrid machine. I'd like to open it up for questions if anybody has any, and I'll try to answer them to the best of my ability. So the question was, what sort of metalworking fluids are being used in the machine? That's really dictated by the part that you're running. Typically, most of the Davenport machines out there run oil in them. There's probably 100 different grades, but there are several customers out there that are running water-based coolants as well. Yes, this is a servo-driven pickoff, so it's completely independent from the work spindles. We have the ability to match the work spindle, and if you're doing hex diameter bars and you have things of that nature, we can sync up with the work spindle, come over, grab on a hex, bring it back. We have the ability to stop it, orient it, use right-hand tools on the back burring side. So something that, you know, Model B users might be familiar with is the exclusive use of left-hand tools on back burring. This allows you to go into a more standardized tool. We even have the ability to back tap. So if you have a tap hole blind on the back side of a part that normally you'd have to run in the other orientation on a Davenport to get the tap in using a tool spindle, we now have the ability to go in there, back drill and back tap on the back side of a part, introducing two different tools into the back of a part. The RPM on that will go up to 6,000 as well.
What kind of controls are you using? Is it PLC-based or PC-based?
They're PLC-based controls by B&R. They've been our control vendor now for over 20 years. We have a great history with them. Highly reliable equipment. We're very happy with them. Anticipate using them for a long time in the future. Well, thank you for coming to the demonstration today and your questions. And we'll be taking orders in the booth.